Welcome all, welcome to this lab of object-oriented programming. Today we'll be continuing with programs. We already done up to 1 to 9 program, so we'll be starting with program number 10. Let me show the disclaimer first, then we'll start the lab. Okay, so let's start the session. Okay, and so we have seen this list of experiments, and in this we started from practical number 1, which was a very simple program, and from that we have come up to practical number 9. We have done 9 practicals till now. So today is the turn of practical number 10. Okay, let's see practical number 10. In this, it says that write a test program that prompts the user to enter 10 numbers, okay, and invoke a method to reverse the numbers and also display these numbers. So we have to do what? We have to do 3 things. One is to read the 10 numbers from user, and then reverse those 10 numbers and then display those 10 numbers. Okay. So for this, let me show what we'll do. So here in this practical number 10, we have this program. We made this program, and here what we are doing is that we are saying please enter 10 numbers first. Okay, so first thing that we do over here is, let me show you. Let me just make it bigger. Okay, check this out. The first thing that we do over here is we declare an integer array of size 10. Okay, once we have declared the integer array of size 10, then we get the scanner object so that we can read the input from the user, from the console, and then we say please enter 10 numbers. And after saying please enter 10 numbers, we use the for loop to read those particular 10 numbers. So the loop starts from I equal to 0 and goes up to the length of the list. Okay, and with each iteration it will do what? It will read a next integer and will put it into the ith element of that particular list. So in the ith location of that array, the new integer will be put. The integer will be inputted by the user. This input will be given by the user. Okay. So we read 10 numbers from the user and put those 10 numbers where? Into this list array. Okay. Then we print it out. We say original array. This is the original array. Okay. We say original array is basically this one. So what do? We simply print it out. We say int I equal to 0 in the for loop, we go up to its length, and one by one we print it out. Along with that, we concat one space with it so that the whole array gets printed into a single line, and all the numbers are separated by a space. Okay. So once this for loop has been done, we send that list to the reverse method, right? And in this reverse method, what we do is, in this reverse method, after the reverse method finishes, we simply print the reversed array. So let's check what happens. Here we pass the list array, which gets passed to this parameter over here, which is also with same name, list, and the control is passed to this reverse method. So what happens to that particular array? We know that what happens when we pass an array into a method, right? The reference variable is passed. The value of the reference variable is passed. So the next reference, that is this particular reference, also starts pointing to the same array. So what happens in the sense that there is an array created. There is an array created, and it is of about 10 numbers, right? And it is of about what? It is of about 10 numbers, right? And the best thing is that this particular list is pointing to this array, and when we send that list over here as a parameter to this reverse method, then this list variable also starts pointing to this particular array. Okay, so that's the best part. The array itself is not passed. The array itself is not passed, but the reference is being passed. The reference variable list is being passed. Since that reference variable list points to this array, this new reference variable also starts pointing to it. And now whatever we changes do in this array will be reflected, will be seen in this method also. Okay. Now let me show you what we can do. So there are two ways in which we can, swap the values. If there is an integer values to be swapped, you can use this methodology also. And to make it simple, I have made this three-line code. What we will do over here is, see, we will basically start from int I equal to 0 to the half of the list length. Okay, so let me show you what happens if we have this array. Okay, let me just make an array of about 10 numbers. So let's say we have 1 2 3 4 5 6 wait, let me just click for 1 2 3 4 5 6 7 8 9 and 10. So we have 10 numbers in hand. Okay, and this array is being created for 10 numbers. Okay, now we want to reverse it. We have to reverse it. So let me just create the array. Okay, so once the array has been passed to this reverse, what do? We start from I equal to 0 and list dot length by 2. So see the index over here. If we talk about the index, then the index is something like this. This is 0, this is 1, this is 2, this is 2, this is 3, this is 4, this is 5, this is 6, this is 7, this is 8, and this is 9. Okay, so this is what? This is the index, right? This is the index, right? So now what we have to do is the index will start from 0th location, that is this location, and it will go to list.length minus divide by 2. So what is list.length? List.length is nothing but here the list.length is equal to what? 10. So you say 10 divided by 2, that gives you 5. Okay, so it will start from 0 to up to 5. Okay, so now in fact it will go from 0 to 4 only, not even 5, 0 to 4. So from here the loop starts and it reaches up to this place. So first 5 elements are covered. Okay, now you will say why only first 5 elements are covered? Why? Because each and every element is being swapped with the corresponding element starting from the end. So if these 5 elements are to be shifted, then these 5 elements are to be not directly shifted over here, but one by one, it starts from the first element being replaced with the last element, then the second element being replaced with the second last element, then the third element being replaced with the third last element, and the fourth element being replaced with the fourth last element, and the fifth element being replaced with the sixth element. Okay, so in this way the replacement will happen. Okay, so once that replacement happens for at least 5 elements, then whole array is automatically sorted. Okay, or I mean it has been reversed, not sorted, but it has been reversed. Okay, so see what happens. We say when int temp equal to list of I. So in this first iteration, let me show you what is the value of temp and then list, and we say list of I, and then what is the list of list dot length minus 1 minus I. Okay, okay, so now this, let me make a table of this. And here we can even add the value of I. Okay, so you will see that how we can Okay. Now this is what is the table that we have made. Okay. So now the value of I will go from start from 0, 1, 2, 3, and 4. It will go up to this part only, right? The value of I will start from 0 to up to 4. So there are 5 iterations of this particular loop. Okay, there are only 5 iterations of this particular loop. Let's see what are those. Okay, so in the first iteration, temp is equal to list of I. So what is the list of I? List of 0 is what? 1. So the temp value becomes what? The temp value becomes 1. Now what is list of I? List of I is also 1 at that time, right? That is also 1 at that time. And when the, what is list of list dot length? Okay, we'll see one by one statement. So first statement makes temp equal to 1. Okay, temp equal to list of I, so that is 1. Then the second statement is list of I is equal to list of list dot length minus 1 minus I. So what is the list? The length of the list is what? It is 10 minus 1 minus what is I? I is 0. So this is equal to saying 10 minus 1, which is equivalent to 9. So the this ninth element is being taken into consideration of the list, and that is being given over here. First, which happened? First, this assignment happened, then this assignment happens, and then this assignment happens. In this way, swapping happens. This is called as swapping. The value of this assignment goes over here, and the value of here this goes over here. This is what is called swapping. Okay. So what was that? It was number 10. So list of I is now become 10. And then in the end, we say list dot length minus 1 minus I is equal to 10. So here it is what? Value 1. So you can see now the array has been swapped. Okay, now if you see, the array would be swapped. Okay, so now we have 10 elements, and now what happens? Now the value of this 0th location has become what? It has become 10, and the value of this 9th location has become what? It has become 1. Okay, this 9th is this particular location. Okay, this particular location. This is 8th location, this is 7th, this is 6th, this is 5th, this is 4th, this is 3rd, this is 2nd, and this is 1st. Okay, and this is 0th. Here also this is 0th, this is 1th, this is 3rd, 2nd, 3rd, 4th, 4th, 5th, 6th, 7th, 8th, and 9th. Okay, so now this one iteration swaps 2 places at a time. Okay, now let's see what happens in the second iteration. In the second iteration, the value of I has become 1, right? And what is the value of temp? Temp now is again defined. So now temp is equal to list of I. So what is list of 1? List of 1 is this 2, right? So the value of temp becomes what? 2. And now we say list of I is equal to list of length minus I minus 1, or that is equal to saying this is equivalent to saying 10 minus 2. Okay, this is equal to saying 10 minus 2, that is 8. So list of 8 is what? List of 8 is 9. So the value that we get over here in list of I is number 9. And then this temp's value is given to this location, list dot length minus 1 minus I. So this 2 goes over here, and so that's why this new value over here is 2. So you can see that this location gets the value as what? As 9, and this location gets the value as 2. okay, in the second iteration. So again, now we have 4 places in hand. We have swapped with, 4 places have been modified in the array. Now we are remaining with 6 places. So in the next iteration, again the value of okay, just a minute, let me write it. 2. Okay. Now in the next iteration, the value of I has become 2. So temp is equal to list of 2. What is list of 2? List of 2 is number 3. So temp gets value 3. What is list of I now? List of I is equivalent to list of list of length minus 1 minus I. So this is equivalent to saying 10 minus 1 minus what is value of I? 2, which is equivalent to saying 10 minus 3. 10 minus 3, which is equivalent 10 minus 3, which is equivalent to saying 7. Okay, so what is list of 7? List of 7 is 8. Okay, so the value here we get is 8, and then this last swapping happens, and this 3 value is put over here, and here we have number 3, and so that's why now in this iteration we have here 8, and here we have as 3. Similarly, what happens in the next iteration? The value of I is 3. So temp is equal to list of 3. What is list of 3? List of 3 is 4. So the temp gets value 4. And similarly, list of I, according to this particular statement, what do we get? List of length is 10 minus 1 minus what's the value of I? 3. So it's equivalent to saying 10 minus 4, which is equivalent to 6. So if we say list of 6, what is list of 6? That is 7. So here we get the value 7. And then we swap, and that location we swap the value of 10. So we get number 4. So if we see this over here, the number 7 comes, and over here the number 4 comes. And so in the last iteration, similarly, what happens? Temp's value is 5, and list of I's value becomes what? It becomes 6, and similarly here it becomes 5. So in the end, the array becomes like this. This is 6, and now this is 5. That's it. And now the array has been reversed. This is what? This is a reversed array. Okay, and this was the original array. What was this? This was the original array. Okay, so you can see how we swapped the values with only just half of the iterating over the only half of the array. We were able to swap all the values and just reverse out the array. Okay, so we reversed the array also, and also we reversed the numbers that are inputted. So let me just save this, and let me say array reverse. Okay, that's it. So now let me run this file. Understand what happens? We declare an array of 10 numbers, read 10 numbers from the user one by one using the for loop. Then we display the original array. We send the array to reverse method, so that reverse method will swap all the elements one by one and reverse the whole array. And then we display the reversed array using the same kind of for loop. Okay, let me run this out. I say click on run. Okay, it says please enter 10 numbers. I will enter 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And so this is the original array. You can see that this is the original array, and this is the reversed array. You can see the difference, original and reversed. Yes. So actually this was the sequence in which it was entered, but now it has been reversed. Okay. So that is how we get 10 numbers from user, invoke a method to reverse these numbers and display the numbers. So we have to store the numbers into an array, then only we can sort it out, or you can reverse it out. Understand? So we didn't need a data structure. So what is the data structure over here in hand? List. What is that? That is an array. Okay, the name of the array is list. Okay. And this is a different another method that you can try it out. Okay, try to try to comment this part out and uncomment this part, this 3 lines, and then run the program. This will also run, and try to understand what is happening in this case. Okay, I'll leave it to you people to understand what this thing is doing. Try it out, explore it out, and see what happens, whether this works or does not work. Please do tell me next time. Okay, so that is practical number 10. Now if we see, now let's go to practical number 11. Now if you see practical number 11, we have this program as, it says that you have to write a program that generates 6 by 6 two-dimensional matrix which are filled with ones and zeros, or zeros and ones, and display the matrix, and check that you have to make sure that you have to check that every row and column have an odd number of ones. Okay, every row and column should have an odd number of ones only. It should not be an even number of ones. It can contain zeros, any number of zeros, but there should be odd number of ones inside it. It may be 1, 3, 5. Okay, since it's a 6 by 6 matrix, only these 3 combinations are possible: 1 or 3 or 5. So the number of ones in any column and in any row should total up to either 1, 3 or 5 only. Okay, so let's see that particular program. So see, okay, Manish is saying it works from both the method. Okay, Manish, no issue. I know that it works. This program, practical number 10, works. You can even use this, and you can even use this. That's right. That's correct. You just have to understand what this thing is doing exactly. Okay, this thing I would just tell you is equivalent to saying something like this. If you have 3 values, A, B, right, A and B, let's suppose you have only 2 values which are of type integer. So if you have int A and B, okay, and let's say A has got value 10 and B has got value 15. So what happens is, if you want to swap these 2 values and these are 2 integers, then there is one more way. Without using a third variable, you can swap it, and that is like this. You can use A equal to A plus B, right? So which is equivalent to what? Which means that that is 10 plus 15 is equal to 25. Then you say that 25 is A is not, A or B does not have value 25. So still our operation is incomplete. So we say B is equal to, again, A minus B. So A minus B. So that is equivalent to saying, what is A? Now the A's value is 25. Minus what's B values? B values as it is 15. 25 minus 15 is equal to 10. So now the value of 10 is swapped into B. You can see the value of A is swapped into B. B gets the value 10. But what about the value of A? So now we have another formula that says A is again equal to A minus B, which is equivalent to saying, what is the A's value? A's value is still 25. Minus what's B's value? B's value is what was the older 10's value. A's value, that's 10. So 25 minus 10 is equal to 15. So you can now see that B's value has been swapped to A. B's value has been swapped to A. So in this way, B gets the 10 A's value, that is 10, and A gets the B's value, that is 15. Okay, and this is the same thing happening in this 3 rows. The same formula has been applied over here. Understand? Okay, so explore it out. Okay, so let's go to now practical number 11. Practical number 11 says that write a program that generates 6 by 6 two-dimensional matrix, and it should be filled with zeros and ones, and you display the matrix and check that every row and column has an odd number of ones only. So see what we are doing over here. Here we are creating an array of 6 by 6 rows and 6 columns. First we declare int array and then we create it. Okay, now the array has been created, but it has not yet got any values, right? By default, what values will it get? By default, all the values are zeros only. Okay, by default, all the values are zeros. Okay, now what we will do is we'll use a for loop. For it starts with I equal to 0 to the length minus 1 to ARR of length minus 1. So what is ARR's length? Array's length is 6. What is minus 1? Minus 1, it becomes 5. So it goes up to I less than 5. So I starts from 0 and it goes, the condition says I should be less than 5. So it goes up to only 4. Okay. So first 4 rows are being accessed over here. Okay. In fact, we can say first, not first 4, but first 5. 0 to 4 is 5, right? 0, 1, 2, 3, and 4. That becomes 5. So first 5 rows are being accessed over here. Okay. Now this first 5 rows, what it will do is, these first 5 rows basically we have to make sure that in this first 5 rows we have put some ones into these rows, and the last row will make sure we'll keep extra the last row, so that if we want to make even number of or odd number of ones, then we can make it. Okay, so what we do is we start from this loop starts from 0 and goes up to 4, 0 to 4, and then we have we have this count equal to 0, and we have another loop where it starts from j equal to 0 to j less than ARR of I dot length minus 1. So what is the length of ARR of ith location? Each and every row has got 6 columns, right? So here also the length is 6 minus 1, that is equivalent to 5, and we say j should be less than 5. So obviously here also this loop also goes from 0 to 4. Okay, that is first 5 columns. So now this what we do is, for that ith and jth location, okay, we invoke the random method of math, multiply it by 2. Okay, so we get some number, either it would be 0 or some one number with some decimal point, but then we convert it to an integer. We cast it into an integer, so we get only the integer number, and that is stored into this ARR of I and j. And then what do we do is, the most important part in this for loop is that we add that ith and jth element of that array to count. So if it is 1, then it is added to count. Since count was 0, it is added to count as 1. If 0, there is no difference in count. Okay. So in this way, we access first 5 columns of these first 5 rows. Okay. And when we have completed the first 5 columns, we check. What do we check? We check if count modulo 2 is equal to 0. Okay. Then what to do? So see, it's something like this, that we have this array that is, let's say 6 by 6. Let's try to make a 6 by 6 array. So this is a 6 by 6 array. Okay. And let me just try it out. Okay. So now here what we do is the index starts from 0, 1, 2, 3, 4, and 5. And here also the index starts with 0, 1, then 2, and 3, then 4, and then 5. And now here what we will do is oops, that has been deleted. So let me again try it out. A 6 by 6 array. Okay, instead of making it index, let me open up a style sheet. In that we will do. Okay, so here let me show you what we can do. Check this out. Okay, let's make a 6 by 6 array over here. Okay. Okay, so this is about 1, 2, 3, 4, 5, and 6. Okay, and this is also 1, 2. Let's keep it number. Yeah, the 6, and this is also 6. So this particular thing is now what? This is now a 6 by 6 array. Okay. So let me have a border to it. Okay. And now by default, this 6 by 6 array has got values what? Values as 0. What it has got? The value as 0. Okay. So let me just put it everywhere. By default, it has got zeros. Okay. Now with each iteration, what we will do is, with each iteration, okay. Okay, now check this out. With each iteration, we try to put 1 up to this part. Okay. So how does it go? It goes from 0 to 0 to this much and this. So this much area, this much area of the matrix is randomly filled by zeros and ones. Okay. Already it has got zeros, and then still we, using this for loop, we put zeros and ones. Okay, so it might happen that this has got 1, this has got 1, this has 0, and this has got 1. Okay, so now here we have odd number of ones. The count here will be what? Count will be 3. Count's value will be 3. So obviously you don't need to add one more 1 in the last location. But what if something like this happens? 1, then 0, then 1, then 0, then 0. That's it. So here what is the count? Here the count is 2. Okay. So since the count is divisible by 2, you can see that in this code, what do we do? In this for loop, after the inner for loop ends, we check whether the count is more divisible by 2 or not. If modulo 2 count modulo 2 is equal to 0, it means count is divisible by 2. Then we say ARR of I, and what is the jth value? Jth value is the last value, that ARR of I is length minus 1. So that is equivalent to saying that this particular length is, what is length? Length is 6 minus 1 is equal to 5. So that is 5. So this is, if I is 0, right, then this is equal to saying ARR of 0 and 5. If I is 1, then it is saying ARR of 1. Okay, it is equal to saying what? ARR of 1 and 5. So you can see this ARR of 1 and 5 represents this part, which this location. What is this location? This location is basically what? ARR of 1 and 5. 1 means the row having index 1, since index here, or let it be 1, but the index starts with 0. So the index is like this. This is 0, and this is 1, then this is 2, then this is 3, then this is 4, then this is 5. So the index starts with what? 0. So this 1 means the second row. And 5 means the index also starts from 0. So here, instead of 8, it is like this: 0, 1, 2, 3, 4, and 5. So ARR of 1 and 5, or ARR of 1, 5 is this location. So there we put 1. So instead of the 0, here we put what? Here we put number 1. Again the for loop runs. Okay, for loop goes into next iteration, and here it may put some number of 1s, and in the end, if it sees that the count of that 1 is divisible by 2, that it means there are even number of 1s in that particular row. So it will do what? It will add one more 1 in the last location. So every time it may add one more 1 in the last location, if at all there are even number of 1s in this locations. Okay, understand? This is what happens, right? So if next time it is something like this: 0, then 1, then 1, and 1 and 1. So it is again an even number of 1s. So here we add one more 1. If we get it something like this: 0, 1, 1, 1, and 1. So it is even number of 1s. So we don't need to add. If we get it something like this: 1, 0, 1, 1, then we don't need to add it. And we get something like this: 1, 1, then we need to add a 1 over here, because the count would have been 2, right? So in this way, we change the count to, here the count is 3, here the count is changed to 3, here it was 4, so the count was changed to 5, here the count is already 3, here the count is also already 3, here the count was 2, so it was changed to 3. So now you can see all the counts are what? Odd numbers. So there are odd number of 1s. Okay. And once this happens, okay, now see, this will not be affecting this part. Only this much part will be affected. This part is still untouched. Why? Because you can see that this for loop goes from I equal to 0 to length minus 1. So it will go up to this part only. And what about this row? So that row is also used to, manage this part. Check this out. Again, what do we do? Again, we use a for loop. Now this considers all the rows and all the columns. Okay, this for loop considers all the. It starts with 0th row, goes up to the last row. Starts with 0th column, goes up to the last column. Okay, and what does it do? First, it initializes count to 0, and for each column in that particular row, it well, actually, it does what? It adds that value to the count. Okay, it adds that value to count. Now, see what happens is here. The difference you have to make sure is this I is kept over here. The inner values I is kept over here, and the outer values J is kept over here. Okay. Okay. So now what will happen is that we have this count, and in this specifically, what we can do is we can get the total of that particular column, not the row, but the column. So see, this I will go from 0 to 5, and J will remain as it is. So it will iterate over the first column. And if the count is an odd number, or sorry, even number, then we add one more 1 at the end. Okay. 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 So let me show you what happens again. Okay. Check this out. Here, what happens in this for loop? Okay. Here J is 0, starting from 0 to 6. Okay. So see, this is number 0th row, 1, 2nd, 3rd, 4th, and 5th. And this part is also starting from 0, 1, 2, 3, 4, and 5. Okay. So these are various indexes. Now here what happens is here, instead of changing the rows every time, we change the column. Sorry, instead of changing the column every time, we change the row. So check this out. What happens? This J, outer J, is put over here. So it remains steady for whole iteration of this for loop. And this I that is currently continuously changing, is put over in the number of row. So what happens? We first get the count of all the addition of this. Then we get the count of all this, then again all this, then again all this. In this way, we get one by one, get the count of each and every column. And if the count is divisible by 2, it means that there are even number of ones over here. So what will be the count? Let's see the count over here. The count over here will be, this count of this column will be what? The count of this column will be 3. So that's an odd number, so not an issue. The count of this column will be what? It will also be 3, so not an issue again. Here also it will be 3, so not an issue again. Here it will be 4. And here it will be 2. And again here it will be 2. So what happens is that these 3 columns have got what? Even number of ones. So what do we do? Check this out. If count of that particular column is divisible by 2, if count modulo 2 is equal to 0, it means it is divisible by 2. It means that particular count has got even number, and it means there are even number of ones in that particular column. Then what do we do is we use the last element of that particular column by saying ARR of ARR dot length minus 1, that is 5, and this jth location. So for this particular this particular column, it is this value, and here instead of the 0 we put one more 1. So now what is the count? Now the count becomes 5. Again for this for this particular column, we put instead of the 0 in the next iteration here we put 1. So here the count becomes what? The count becomes 3. Similarly here also, here we put a 1 in this location and the count becomes what? 3. So now we have got equal number of equal, not equal, but odd number of ones in each row and each column. Understand? In each row and each column. So there it is. You can see that we have got proper number of and if we see over here again, let's see here also we have 3. Here we have what? Here we have 3, and here we have again 3. Here we have 5. Here again we have 3. Here again we have 3, and here again we have 3. That's it. You see that? So we have odd number of ones. Okay, and okay, no, that is not 2. This is also 3. Okay, there are 3 ones, right? Yeah. So there it is. We have now got an array which is having odd number of ones in all the rows and on all the columns. So see what happens is this first for loop, the first combination of for loop is used to make sure that there are even number of ones in each and every row. Sorry, odd number of rows in each and every row, right? And it uses the last column of that particular row. It uses the last column of that particular row to make it an odd number of ones if they are not there, right? And similarly, the second for loop is used to make sure that each column carries odd number of ones, and it uses the last rows, that particular column's last row, to be made as 1 if that particular column has got even number of ones, you see. And then we print the array. What does array do? Print array do? It simply uses the 2 for loops that iterates over the ith and jth element and prints it out. And after each row is printed, we just print a new line. That's it. So it gets printed into a matrix format. Check this out. We run this array, and here it is. Let's see what is the output. What is the output? This is 6 by 6 array. And now let's check. We have 3 ones, 3 ones, 5 ones over here. Here also 5 ones, 3 ones, and 3 ones. Okay, what about column? 3, 3, then 5, then 5, 3, and 3. Perfect. So there it is. So we get, and randomly this will be changed every time. So again we run this. We again run this particular program. We get a different kind of matrix, but it is made sure that each and every row and each and every column has got what? Each and every row and column has got odd number of ones only. Okay, so that's it for today. If at all any doubt, please do let me know. Okay, we will have interaction.